Alright guys, what you're going to be working on today is you're going to be working on a introduction to solving one-step inequalities. So let's do a quick symbol review. We started inequalities yesterday and talked about what all of these symbols mean. So the first one we're going to look at here is our symbol that's got the mouth that comes first and the point that comes second. Okay, that is our greater than symbol. Okay, now the opposite to that is on the other side where the point comes first, and that's our less than. It's saying whatever is on the left is less than what's on the right. Now the two new ones that we talked about yesterday, and it looks like I made a mistake here, but because they're both the same symbol. So if we look right here, okay, this is our greater than symbol kind of squished with an equal sign. So we said that that means greater than or equal to. And then our other symbol, which is right on your paper, just wrong on my screen here, should be a less than symbol with the line underneath it, and that means less than or equal to. So these are our four symbols that we're going to be using today, and we talked yesterday about words that mean those symbols. And today, after you finish your independent practice, you're going to go back to practicing those words. But what we're going to be working on today is we're going to be solving one-step inequalities. And solving a one-step inequality is just like solving a one-step equation, except instead of having one solution, just like we did with equations, we're going to have a set of answers that make the inequality true. Okay, so you should be going along on your notes page with me, and instead of one solution that makes the equation true, we're going to have a set of answers that make the inequality true. So with an equation, for example, we had 6 plus 6 equals 12. There was one solution that made that equation true. Today, we're going to have a set. An inequality might give you the answer, x is greater than 7. Well, there's no one number that's greater than 7. It's a set of numbers. Okay, so this is called the solution set. So on your paper, to define the solution set is just the set of all possible solutions that make an inequality true. So it is just a written down set that includes every single possible answer. Okay, the solution set is the set of all of the possible solutions that make the inequality true. Okay, so to solve a one-step inequality, like I said, it's going to look identical to solving a one-step equation, except the answer is going to be a little bit different. So our goal is still to get that variable by itself. Okay, we're still trying to cancel out all the other operations and isolate the variable and get it by itself. So to do that, the first thing that we do is look at the inequality and determine what inverse operation that it requires. Okay, then we're going to perform that inverse operation to both sides of the inequality. And then last but not least, you're going to write your answer in the form variable, symbol in the middle, and then your solution set on the other side. So variable, symbol, solution. Okay. Now, I hope this sounds really familiar because it's exactly what we did with equations, except instead of just one solution, now we have a solution set. Instead of an equal sign, we have a symbol. We're still using inverse operations. We're still performing it to both sides of the equation. The difference is we're going to have a solution set instead of just one solution. Okay, so we're going to do 4 examples together, and then on the back, you're going to have some independent practice to work on by yourselves. So our first one says x plus 9 is greater than 14. Now, just like when we solved an equation, okay, we're going to draw a line through our symbol. Okay, this splits our inequality in half, and we know whatever we do on this side, we also have to come over here and do on this side. Okay, so we have to look at this side, and we have an addition. The inverse to that is subtraction. And I want to cancel out the add 9 so I can get the x all by itself. So we're going to subtract 9. Now, whatever we do on the left, we also have to come over here and do on the right. So I'm going to subtract 9 on the other side as well. Now, I have a plus 9 and a minus 9. Those cancel each other out, and we're just left with x is greater than. Notice how it doesn't say equals anymore. We have our greater than symbol. Okay. Now we solve on this side. 14 minus 9 gives us 5. So our solution set says x, or our variable, can be anything that is greater than 5. Okay, so in your solution set, 6 would make this inequality true. Is 6 greater than 5? Yes. 7, 8, 500. any number that is greater than 5 could make this inequality true. Okay, so to check, your check is going to be just a smidge different. Instead of substituting in a 5, okay, our solution set says x is greater than 5. So I can't substitute in a 5, okay? I have to pick a number that makes the inequality true. So in this case, I'm going to pick 6, okay, because 6 is greater than 5. Now, we're going to substitute that in just like we did before, okay? So I'm going to take the 6 and I'm going to substitute it in for x. So I have 6 plus 9, and I want to see, does that give me a solution that is greater than 14? Okay, 6 plus 9 is 15, which is greater than 14. Okay, so since 15 is greater than 14, I know that my solution set is true. Okay, I know that the inequality x greater than 5 is the correct solution set for this problem. Okay, all right, so let's look at number 2. Number 2 is our multiplication example, and we have 8n is less than 72. So we're going to, again, split our inequality straight down the middle. Okay, we have our line drawn through the middle of our problem, and we can see that we have a variable right next to a coefficient, so we know that multiplication is happening here. The inverse of multiplication is division, so we're going to divide by 8 to get the n all by itself. Now, whatever I do on the right side, I've got to come over here and do the exact same thing on the left. When we do that, I have a times by 8 and a divide by 8. So those cancel each other out, and we're left with just n is greater than. I'm going to come over here on this side. I have 72 divided by 8. That gives me a 9. So in this case, our solution set is n is less than 9. So any number that is less than 9 will make this inequality true. So to check, we have to pick any number less than 9. Okay, so pick a value that makes the inequality true. Any number less than 9. I'm going to pick 8, okay, because 8 is less than 9. So we're going to take the 8 and we're going to substitute it in for the n and check and make sure that that makes our inequality a true statement. So I have 8 times n. I know that's multiplication. So I'm going to substitute the 8 where I see the n. And I want to see, is that less than 72? Okay. 8 times 8 gives me 64. And 64 is less than 72. So I know that n is less than 9 is the correct solution set for this inequality. Any number less than 9 will make this problem a true inequality. Okay, all right. Number 3, we're going to go with L minus 12 is less than or equal to, notice we have, or sorry, is greater than or equal to 27. Okay, so again, we're going to draw our line through the middle, and the subtraction is happening here. So the inverse to subtraction is addition. So to cancel that out, we're going to add 12 to both sides. Okay, add 12. Whatever I do on the left, I also have to come over here and do on the right. A minus 12 and a plus 12 cancel each other out, and we're left with L is greater than or equal to, and I'm going to solve on this side. 27 plus 12 gives us a 39. So the solution set we found says L is greater than or equal to 39. Any number that is greater than or equal to 39 will make this equation true. So let's check. Any number greater than or equal to 39. So I'm going to pick 40 because 40 is greater than 39, and I'm going to substitute it in for the L. Okay, so we have 40 minus 12, and I want to see, is that greater than or equal to 27? When I subtract, I get 28 on the left and 27 on the right, and 28 is greater than or equal to 27, so I know that this is a true statement. Okay, 28 is greater than or equal to 27, so that means our inequality L is greater than or equal to 39 is a true statement. All right, number 4. We have W divided by 8 is less than or equal to 13. First thing we're going to do is draw our line down the middle of the equal sign and look for our inverse operation we're going to use. So I have W slash 8. Okay, that slash means that we're dividing, and the inverse to that is going to be multiplication. So to cancel it out, I'm going to multiply by 8. Whatever I do on the right, I also have to come over here and do on the left. I have a divide by 8 and a times by 8. Those two are going to cancel each other out, and I'm left with a W that is less than or equal to. Now, when I do 13 times 8, I get 104. So my solution set for this problem says that W is less than or equal to 104. Any number that is less than or equal to 104 will make this equation true. So to check, since we have a equal to symbol there, why don't we just pick 104 and see if that makes our equation true? So I'm going to pick 104 because it is less than or equal to, it's equal to 104. So we're going to substitute that in for the W, okay? So we have 104 divided by 8, and it's going to be, we're going to see, is it less than or equal to 13? 104 divided by 8 is 13. Now we have to check, is this a true statement? Is 13 less than or equal to 13? Yes, it is. 13 is equal to 13, so therefore that statement is true, and we know that our solution set, W is less than or equal to 104, is a true statement. Okay, so today's directions. Now that you've finished filling out your notes paper on the front, what you're going to do is you're going to solve each one-step inequality on the back. So flip it over, and you're going to do the independent practice all by yourself. Okay, so you're going to check your answer with the solution given. Solve, check, okay. You're not going to submit your answers on Google Classroom. You're just going to bubble them in on the grade cam. Okay, bubble them on the grade cam at the top of your paper. And then whenever you are finished, turn your work into the box. Okay, now if you put your work on a separate sheet of paper, which you probably should, so you have room to solve and check, you need to staple that, make sure your name is on it, staple them together so that it's all still attached. Okay, when you are finished, okay, review the Quizlet cards I posted for the words that mean inequality symbols, and or go through them and play the quizzes in inequalities vocab review game. Okay, the more you guys practice that review, the vocabulary from yesterday, the easier it's going to be come test time. Okay, so do all of this stuff, turn your work into the box, and then you're going to review the flashcards and go over the quizzes game that's posted online. Okay, guys, I hope you have an awesome Friday. Now, if you don't get those 16 questions done on the independent practice, you need to finish those this weekend. Okay, all right, have a great day, and I'll see you on Monday.